So let's cover data wrangling in Julia. First, we are going to cover how to import data into Humus using the CSV package and the DataFrame's meta package. The CSV package has a function called read. This function will take any arbitrary text delimited file, so it could be a CSV, a PSV as in tab delimited, and also any custom delimiter file that is in a plain text format. The read function, if you hover over the documentation, takes a source, which is generally a file path, and a sink, which is a certain type P. Most of the time, we want to materialize the file path, the CSV file, into a data frame. So that's why we use the sink data frame. These are the only two positional arguments for the CSV read function. Most of the time, the CSV read function works straight out of the box. So if I run this, and since I'm running the first time, it takes a while. Yeah, there will cease. I run this. It retrieves a data frame. This is a demographics data frame. It has around 100 rows and 6 columns, and it has those columns. And this is how CSV.read parsed our column types. We don't see any problem whatsoever. ID is pressed as an integer, age, weight, SCR, and EGFR are processed as floats, and the isMail, which is a Boolean variable, 0 and 1s, is parsed as an integer. This works fine for almost all of the CSV files, but sometimes you have files like this. So then I put it side by side. This is a preview of the file, and as you can see, we don't have comma separate values. We have actually semicolon separate values, and the decimal is commas instead of dots. And this is a common pattern in the European Union and also in Latin American. And this is this can be handled by CSV.read. You just need to use other keyword arguments such as delim and decimal. Delim specifies the delimiter, and if you go over the read function and you scroll down here, there's tons of keyword arguments. So the CSV read can pass any blank text that you throw at it. And if you go down here, you are going to take a look at the parsing options. So in this parse options, you see that the lim by default is a cha, so it has only single quotes, and by default, it's a comma. We can override this by setting the lim as semicolons, like the file to the right, and we can also set the decimal. So if you scroll down a little bit here, you see that the decimal by default it's a char and it's a dot. We can also use a comma. And that's pretty much what we are doing here. So if we run this line, we get back the same data frame, and CSV read can handle any type of a file, of a delimited file, data file that you throw at it. So this is a common options for European or Latin American formatted data sets, the CSV files. Now, as you can see, let me close this. As you can see, some columns, they were parsed automatically as certain types. If you want to override that, you can do so with the keyword arguments types. In this keyword argument, I'm passing a dictionary with the following idea. The column names, they are the keys of the dictionary, and the types are the values. So if I say column name ID and this arrow notation string, I'm telling the CSV read function to parse the column ID as a string and then column isMail as a Boolean. Right now, they are being automatically parsed as integers and both as integer 64. Now, if I run this, you see that the ID now is a string column and the Ismail is a Boolean with the implicit conversion of 0 to false and 1 to true. I can also select and drop columns. There is a select keyword argument in this csv.with function. I can either use as strings to select certain columns. So if I run this line, I get back a data frame with only the columns that I selected. I can also select as a vector of indices as integers. So this will select just the first and the second column, and they are indeed the ID and the age column. So I could either pass a vector of strings or a vector of integers to be parsed as indices. So this is the first and the second column. Analogously, I can also choose for the CSV function .read to drop some columns. And I can pass those columns as either a vector of strings or a vector of indices as integers. So this, I'm telling the csv.with function to drop the columns SCR and EGFR. And it returns a data frame with all other columns except those I ask it to drop. And the same I can do with column indices. So we get back also the same effect here since we are dropping the fourth column, which is this SCR, and the sixth column, which is the EGFR. One important thing is how to handle missing values. These are very important when we are reading NM-TRAN or no-man formatted datasets for our pharmacometrics workflows. I have another CSV file here, and the first row, I added a bunch of different nonsense values. So if you have a missing, sometimes they are hard-coded as NA in the CSV file. Or we can also get some creative stuff like, I don't know, prof, or also a question mark. We can do all of those if you go back to the csv.with documentation and you go down to the parsing options. The first one is missing string. For missing string, you can pass in either a single string, a vector string, or nothing. And this will be all of the values that csv.read will be using to pass those as missing. So generally in no-man, you would want to do something like missing is strings, or is just missing string equals a dot. You will do something like this just to parse no-man formatted data sets. So here we have those strange values, and if I run my data frames csv.read, this file with the missing values, the demographics _missing, you see that we get a lot of warnings. And we get like age has been parsed as a string, weight as a string, and it's mayo also string, and this is not what we want. We can do that by adding the missing string keyword argument and passing a vector of strings to tell the csv.with function to treat all of those string values as missing values. Now, if I run this, I get back a data frame where I get missing values here, and csv.read also parsed those correctly. So the age column is float, the weight column is float, the Ismail column is int64, and so on. And this question mark here is data frames telling us to pay attention to this column because this column has missing values. So whenever data frames detects missing values, it will pre-paint a question mark in the element type in the subheader here. So you know that this column here has missing values. It's just a warning for you to check. That's how you import data using the csv.read function. Next, we are going to cover how to do data ranking and use DataFrame's method.